Okay, so we have been working with trees, and the last class we did some interesting things. We did the Huffman code, and we did the Adelson-Belsky-Landis left rotation, right rotation, so on and so on. And that AVL sticks around, that concept. And if we get to it, we're going to use it, take a look at it today, which I'm pretty sure we will. But we're now moving on to 15.3 in the NIOF book. And you're starting to see, hopefully now, why the NIOF book is our auxiliary or our second textbook, because there are a bunch of really good sections in it that I wish were in our other book that we could use, but they're not. So anyhow, in chapter 15, section 3, we're going to look at today something called 2, 3, 4 trees. Okay, and again, we're back to this whole idea of searching and how can we speed up searching a little bit instead of like we had with the binary tree. We talked about that being big O log base 2 of n. And, you know, how can we make this faster? What are some other options? The first one we're going to take a look at is something called a 2, 3, 4 tree. And it's going to be called a 2, 3, 4 tree because of the options for the number of pieces of data we can store and the number of pointers we can have coming out of each one of the nodes. So we're going to start with, we can have trees with, with more than 2 options, right? We can have an M node to search a tree, and an M node, the M means the number of pointers that would come out of it, and the M minus 1 is going to be the number of data values. Okay, so number of data values and number coming out. For example, if I do this 2, 3, 4 tree, I'm looking at 4 nodes, which means I can store. Hang on 1 second, sports fans. What am I looking for? There it is. Got it. Okay, so here's what we have. Each node can store up to 3 data values. And I'm going to come down here and take a look at, here's an example of what we're talking about. Okay, so we have all these parts, but I need the whole to follow along. And in the whole, you start to see that I can store as many as 3 pieces of data in each node. So my struct is going to be pointer, left value pointer, right value pointer, or middle value pointer, right value pointer. I'm going to have 7 different things inside of my struct. Okay. For this guy, all leaves are going to be on the same level. So we're going to have to take a look at some things like, how do I construct this? How would I insert something? How would I delete something? And it goes into quite a bit of depth, but I think we're going to basically look at how we construct this and maybe how that we search it to see what's going on. All right, so as you can see right below, I have an example. Some of the nodes are completely full. Some of the nodes are not. Some of the pointers point to other nodes. Some of the pointers point to nothing. So now we're going to take a look at how would I build this search tree. I can't use the word binary anymore, but I can build a search tree that can have up to 3 data elements inside of each node, and how I get ready to search. So if I think about searching now, if I say, where would the number, give me a number between 15 and 60.
40.
40. So I'm going to come into this node and I'm going to say, first guy, are you 40? The answer is no. Then I'm going to say, are you less than this number? The answer is no, so I move over. Hey, are you 40? No. Is this, you know, is 40 less than this number? No, so I don't go down that path. I come over here. This is null. So now I'm going to come back and say, well, it's greater than this 38, so I'm going to have to go down this path and sort. And now I'm going to repeat what I just did. Check the first guy. Is it 40? No, it's less than, but the pointer points to null, not found. So it's saving me In a binary search, I have 2, 4, 6, 8, 9 elements. You know, my binary search, I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. I may have 4 levels I have to go down instead of 2. And in the binary search, you know, we would be doing a value, a value, a value, a value, a value, a value, and a value. So if I start looking at levels, I can store 1 item, add these 2. My next level would be 3 items. Add these 4. My next level, you know, I could now have a total of, I didn't add the 4. 7 items takes me 3 levels. The next level, there would be 8 more. So to go 4 levels, I could store 15 items. Well, if I come up here in my first level, I'd be storing 3 items. How many would be in my next level? What would be the total number I'd store? Once again, down here, this level was 1. If I talk 2 levels, I stored 3. 3 levels was 15. I start to see a pattern. I add 2, I add 4, I add 8. Here it's 3. What would the next level be? Total? Well, here's
12.
3. Go ahead.
Wouldn't it be 12 plus 3, which would be 15?
Yep. I'd be adding 12 more. If I went 1 more level, how many data items would I be able to store?
$48.
48 plus 15?
Yeah.
63? 63? Somebody have the next number real quick because you're good with sequences. I got it already.
192.
How'd you get 192? I'm going to say you're wrong because that's an even number and I know. Are you saying it's 192 plus 63?
Yeah.
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 Okay. 192 plus 60.
255.
255. I'm looking at, yeah, if I added 1, this is 2 squared minus 1, 4 squared minus 1, 8 squared minus 1, 16 squared minus 1. So that goes back to your pre-calc days when you were doing it. But anyhow, this guy, this binary search tree, I had 4 levels. If I change my nodes, I can store just as many in 2 levels. So it possibly could be a faster way to search. All right, so let's build this 2, 3, 4 tree and see what's going on. How do I build it? All right, I'm going to do this in pen, so don't let me mess it up. And let's see what my numbers are. Ba, 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 ba. All right, it's clear, you can see it. First number is 53. Again, I wish I was in the classroom because I would have 3x5 cards and I would be taping them on the wall and they would be a whole lot easier to use. Okay, but for now it's just, I'm going to go with 53 and I'm going to go with the reality of this is something that looks like that. I stored the 53. Okay, so far so good. Everybody seems to be happy. All right, so what's my next number? My next number is 27, and I'm thinking, well, I can keep that in the same node because there's room. So, I mean, I'm not going to keep drawing this every time because we would be here forever and you would be as bored as I am. Next number is 75, and I can actually put it in there. So first thing I'm doing is checking to see if there's room. If there is, then I need to decide which one of these I'm putting it in. So it looks like I don't have to put it here or bump those 2 over, you know, so there might be some bumping going on. So once we get the concept, we'll be like, yeah, okay, yeah, I got it. Oh boy, the coding could actually become really hard. All right, so that's what I have. Next number I want to put in is 25. And I look and go, uh-oh, I'm going to put 25 in. There's no room to hold it. So I'm going to split this, keeping the middle value. The middle value is 53. And now I split. Over here is 25, 27. Over here is 75. So I went to my next level for my number of numbers. And as you can see, it's still going to be a fairly quick search. My next number is 70. I can throw 70. It's greater than, I'm going to go to here. My next number is 41. That's going to be able to go to that node. So I need to rewrite it. 25, 27, 41. They're over here. Whoops, that was sloppy. 70 and 75. They're over here. So far, so good? All right, so I just put in 70. The next number I want to put in is 41. I put that in. So let me keep track up here. Next number I want to put in is 38. Now, where would 38 go? Well, it's going to go to the left of 53. But when I put it in, this guy becomes full. So now it's just the opposite of what we did up here. When my root was full, I went down. Well, now that my child is full, I'm going to try to go up. And in this case, I can go up. So when I get ready to put in 38, I'm going to split this by sending the middle value up. 27 and 53 are now up here. What's to the left of 27? Well, the 25. What was the number I was putting in? 38. So when I put the 38 in, I know it's going to the right of 27. So now 38 and 41 are going to sit here. And to the right of 53 is still 70 and 75. So when this guy got full, I had to break down. I put the 53 at the top, sent 25, 27 over, sent 75 over. Here I got full. I wanted to put in 38, so 27 went up. 25 was the left pointer. 38 and 41 became that second pointer. 70 and 75 moved out to there. The next number I want to put in, if I can find it, I just put in the 38, right? 16 and 59. So if I say 16, that's good. I can put it in right here. 59, where's that going to go? Over here. So this is now 59, 70, and 75. The next number, 36 and then 73. Where will 36 go? Well, that's going to go in this node. 36. What did I say next? 73. 73 is greater than 53. It comes in here, and what's going to happen? It's full, so now I have to see, can I bump up? Yes, there's room to bump up. So what's going to get bumped up? The middle value, the 70. So now I'm going to have 27, 53, and 70. Because the 70 went up. I'm still going to have the 16 and 25 here. I'm going to have 36, 38, and 41 here. I'm going to have 59. What was the number that I just added? 73. 59 will be here. 73 was on this side. So out here will be 73 and 75. Okay. So far, so good. Oh, what else do I? A 65. Where does 65 go? What's going to go in here with 59? I have a 60. That's going to go in here. 59, 60, 65. I have a 46. 46 is going to go where? Well, 46 is going to go in this guy. Okay, but can I go in him? No. So I want to try to, I'm sending him up. But remember back when I inserted something in here and the root was full, what did I do? I broke it down again, right? So now I'm going to have 53. I'm going to have so I tried to put 46 in here, right? And I couldn't, so I had to send the 38 up. The 38 caused problems. So I'm going to break it down. Here's the 27. Here's the 38. Okay. What else did I have? The 70. Now what happens? Here I have my 16 and 25. To the left of 38 is going to be the 36. The 36. To the right of the 38, because remember, 38's the one went up and joined with 27. To the right of 38 is going to be the 41 and the 46. Out here with the 70, to the left of 70 is 59, 60, 65. And to the right is going to be 73 and 75. Okay, I'm going to add 55. So where is it that I add numbers? I always add them at the bottom, right? So where would the 55 go?
I'm going to try to go into the right.
It's going to go to the right because it's greater than 53. It's going to come here and it's going to jump into this guy, correct? When I try to put in here, I say, uh-oh, Rain Man, I can't put 55 in here, so I need to send the 60 up, and I can send it up. So this left side is now going to become 60, 70, right? I was inserting 55, so it's going to go to the left of the 60 with the 59. Okay, here's going to be the 65. And here's going to be the 73 and the 75. So this guy would get moved up. Next number's 33. Where would the 33 go? It's less than 53. It's between 27 and 38. And the 33 would go right here. 68. Where's 68? 53, well, my 53 actually jumps to here now, right? It's greater than 53. I come down here. It's between 60 and 67, so it's going down here. 79, greater than 53, greater than 70, it's going down here. And as you can see, once one of these becomes 4, I can bump a number up. Once one of these becomes 4, I still have room to bump a number up. And I even have, once these fill up, I can still bump back up to my root node if I had to. And of course, the last number I had was 48, which would sit in here. So as we mentioned a little while ago, I can get 3 numbers, 15, I could get 63 numbers in what I'm working on now. Level 1, level 2, and then down here, level 3. Because I have a lot more I can build to the right by adding in here. Questions? Thought that was pretty. What's that?
This is just search optimization?
Yep. Yep. So it's for faster searching. Now it takes longer to build, as you can see, but faster searching. Shall we try it again? Do you want to run through the same numbers?
Yes.
Okay. Do you want me to give you about 5 minutes to see how far you can get on your own?
Sure.
Go ahead. All right, so redoing it again, I've already put in the first 7 numbers. The 53, 27 goes with the 53, 75 goes with the 27 and 53. The next number I try to put in is a 25, so I have to do the split and I leave the middle. The middle goes, the 25 goes with the 27, the 75 to the right. My next number is 70, goes to the right of 53. My next number is 41, it goes to the left of 53. My next number is 38, it goes to the left of 53, but I need to split. And when I split, I go up, I move the 27 up, the 25 goes to the left, the 41 goes to the right, and the new number 38 that I was putting in goes to the right as well. I think I like drawing them out like this a little bit better. Next number is the 16. So the 27 and the 53 are good. The 16 is going to go to the left of 27 with the 25. Here's the 38 and 41. And out here is going to be the 70 and the 75. 16. The next number is 59. 59 is bigger than 53, so it's going to go over here. 27 and 53, 16 and 25, 38 and 41. And the new number is 59, 59, 70, and 75. So I just added 59. Next number is 36. Which nodes it going into? 1, 2, 3, or 4?
3.
3. It's going to go in 3. Okay. So now I have 27, 53. I have 16 and 25. I have 38 and 41. And excuse me, I forgot the 36 in here. 36, 38, and 41. And out on the end, I now have 59, 70, 75. That guy's full. That guy's full. That guy's not. And that guy's not. That parent's not. Okay, so I just added 36. Now the next number is 73. And the 73 is going to go into this node, which means I need to split this node up, and I can check and go, yep, I can go up. So I'm going to move the 70 up, the 59 to the left, the 75 to the right, and the new number 73 is going to go to the right as well. So what do I have? I have 27 and 53, and now the 70 is coming up, and the 70. Out here I have 16 and 25. Between the 27 and 53, I still have 36, 38, and 41. Between 53 and 70, between 53 and 70 is going to be the 59. And to the right of 70 is going to be my new number, 73 and 75. Next number I want to add is 60. I just added 73. I'm sorry, the next number I want to add is 65. 65 is going to go in this node, correct? I'm just going to do it that way for now. 60 is going to go in this node as well. Uh-oh, this guy's full, this guy's full, this guy is full. 46. 46 is between 27 and 53. And now I want to try to put 46 in here. 46 can't go in because it's full. What number goes up?
38.
38. 38 tries to go up, but it's full. So who's the 38 going to attach to? It's going to attach to the 27. Okay, and we're going to split on the 53 again. So now I have 53. I had to go to a new level. 53. 53 has two guys coming out of it. The numbers to the left, which are the 27 and the 38. And to the right is going to be at 70. Okay, to the left of 27 is still going to be 16 and 25. Okay, between 27 and the 38 that went up was still this 36. And greater than the 38 is the 41 and the new number I tried to add, which was the 46. Out here, less than the 70, I'm going to put in the 60, excuse me, the 59, 60, and 65. And out here, the 73 and the 75. So you start to see if it's full, I bump up if I can. And if when I bump up, it's full, then I have to bump back down. So 46 went in, 53, excuse me, 55. Where's 55 going to go? It's greater than, it's less than, it's going to go here, but here is full. So when I try to add the 55, something's going to get bumped up. What gets bumped up? The middle. So I have 53, 27, and 38. Out here, now it's not 70, it's what I'm bumping up. The 60 is going to go up with the 70 now. Okay, over here, I still have 16 and 25. I still have 36. I still have 41 and 46. Here, I moved the 60 up. What's to the left of it? The 59, but also the new number, 55 and 59. Between the 60 and 70 is going to be what was to the right of the middle number, which is the 65. And to the left of 70, 73 and 75. Cool? You got it? That was 55. 33, that's going to go in here. 68, that went out here. 79 tries to come out here. And with the 68 in there, 68's in here. But I think you got the idea by now. True or false?
Complicated, but yeah.
In between.
In between? Well, do you want me to give you some numbers and you try one on your own? Okay, good. Let's do that. Somebody start shooting out numbers between 1 and 100. Unique numbers.
70.
Keep going.
17.
5,
23.
31.
11.
48,
1.
48. What else?
21.
21. Keep going.
19.
19. 3 more.
3.
Keep going.
6.
6, 68, 75, 72. All right, you write the numbers down. Here we go. All right, 70. Yay, got that one right. 17 and 5. Next number I want to put in is the 23. So when I do this, I'm going to split on 17, 5 to the left, 23 and 70 to the right, because I just put that 23 in. Next number I'm putting in is 31. 31 is going to go to the right of 17. So 31 goes in here. This is what my new one looks like. Next number is 11. It's going to go to the left of the 17. My next number is 48, which means I'm going to split and send 31 up, have 23 to the left, have 48 and 70 to the right. Questions yet? My next number is 21. 21 is going to go down here with 23. That fit in there pretty nice. My next number was 19. That 2 goes down here in this middle one and fills it up. My next number was 3. It's going to go over here to the left, and it's going to sit there. Starting to fill up here, right? I'm reaching my limit. This one's full. This one's full. These two are almost full. But up to the number 3, is this where everybody's at?
I forgot 48.
Oh, that makes a difference.
Yeah, it did. It did.
Wait, there's a 3 in here?
Yes.
Oh. Okay.
It's
Yeah,
really hard to keep track of numbers.
We have some slight copying issues, I guess. That could be the problem. I used to do math problems and put them on the board, and is this what the original problem looks like after I'd write it on the board, just to make sure I didn't mess up. Doing matrices, that's another thing to check. All right, so I'm copying that, and I laid it down. This is where I'm at. Next number I want to insert is a 6. A 6 is going to go in this node. It's full, so I'm going to send the 5 up, and I can. And then to the left of 5 will be the 3. To the right of 5 will be 6 and 11. To the left of 5 was the 3. To the right of the 5 was 6 and 11. The next number is 68. 68 is going to go out and fill that node. It's kind of nice. Now this node is full. This node is full. My parents' full. Fortunately, you guys did a good job. You picked the next number. Well, I picked it, I think, of 75. 75 is going to come to here, but now I have trouble because I need to send the 68 up. So the 68 is going to come up, and as I know, when I go into a parent node, if it's full, I'm going to split. This time I'm going to split on the 17. The 5 is going to go to the left, the 31 and the number coming up, which is 68, are going to go on the right. So 68 goes up, it fills, so I have 17, I have 5 on the left, I have the 68 and the 31 on the right. To the left of the 5 was the 3, to the right of the 5 was the 6 and 11, to the left of the 31 and 68, to the left of 31 was this guy. Between them is going to be just this number here, 48, and to the right would be 70 and 75. And most of you ended up with that, correct?
Besides lacking 48.